Welcome, ladies and gentlemen. Today we're going to talk about radical operations. You need your flip chart that we created last week. You also need your perfect roots chart. That's going to be very important for today. A calculator and a pen and or pencil. All right. This is the flip chart that you need. Today we're going to be working in our last section, our radical operations. All right. Now this doesn't need to go into your notes, but this is stuff that we've previously done that we're going to work in with today's idea. So here we have to simplify the square root of 50. In order to simplify this, we have to find a perfect square that goes into 50. So the largest perfect square that goes into 50, if we look at our perfect roots chart, is going to be 25. And 25 times the square root of 2 is the same as the square root of 50. Now if we break this down, the square root of 25 is 5. We can't break down the square root of 2, so we're going to leave it as the square root of 2. And that is our answer for that one. Now if we come over to this one, we're working with perfect cubes. So we need our perfect root chart out, and we need to figure out what the perfect cube is that goes into 54. So I'm going to break it into perfect cubes that work and perfect cubes that don't work. So a perfect cube that goes into 54 is 27. Now 27 times 2 gives us back here at 54. So that's done now. Now I have to worry about this x to the fourth power. Now if this is cubed, only x cubes can go in, so this is going to be x cubed here, and I'll have 1 left over, so I'm going to put it over here. When we simplify this one, the cube root of 27 is 3. Those are going to cancel. We're going to get 3x times the cubed root of 2x. Now this is what we've done earlier this week. Now we're going to use this to do a little bit more. So now we should have our flip chart opened up. This top part we're going to have 2 little key definitions, and then here we're going to have 4 examples, okay? So the bottom of 4 examples, the top 2 will be the definitions. Here's our first example that we need to make sure that we get into our foldable, all right? So this should be the first thing that we're writing down in our foldable. When we have 2 radicals that have the same index, if we look at this right here, we can multiply them together to try to simplify them. So we're going to put it all under one root, so it's going to be the cube root, and we're going to take 4 times 16, which is 64. Now if you check your perfect cube root and you look under the cubes, 64 is a perfect cubed, and that is just going to be 4. So there's our answer for that one. That's our example number 1. Example number 2 is like this. We're going to be working with division. Now in this one, if you notice also, we have the same roots. When we have that, we can put them under the same root together. So we're going to have 80 divided by 5. So if I simplify that, I'm going to have the fourth root. 80 divided by 5 is 16. And 16 is a perfect fourth root if we look at our perfect roots chart. And that's just going to be 2. So that's our final answer for that one. Make sure we have both of these in our notes, please. Now, this one you don't need to put in your notes, okay? Don't put this in your notes. We're just going to take a look at this one. If you look at this one we cannot combine, because here we have 3 and here we have 4. So we can't do any combining on this problem. All right? Same with this problem over here. Since this has 4 and this technically would have a 2, right, because it's a square root, we cannot combine these together because they have to have the same root. We could simplify them separately, but since they have the same root, we cannot combine them. All right, with all of that, you need to write your first note right up top. So we should have 2 examples already done right here. This right here needs to get into your notes. It says when we multiply or divide, you only get to do this if the index is the same. Okay, you may use one radical sign, so we can combine them and put them all under one radical sign. So that's very, very important though. The index has to be the same. So if you're not sure what the index is, if I draw a radical sign, this number that's right here, so if I put a 3, that's the index. The indexes have to be the same. Okay? Alright, we're going to move on to our last 2 examples. Here we go. Now we're going to add Okay, we're going to be adding and subtracting. Now when we add, we have to have the same index again. And we have to have the same number underneath our radical. So our radicand, this numbers have to be the same. Right now they're not, and we can't simplify the cube root of 5, so we're going to keep that. But we're going to break down the cube root of 40. So we're going to add this. If we look at our perfect roots chart, we'll see that we can break this down with 8 and 5, because 8 is a perfect cube, 5 is not. Now we're going to simplify this, so we're going to get 3, or the cube root of 5, plus this simplifies, the cube root of 8 is 2, cube roots of 5. Now that we have the same index and the same radicand, so it's the same number underneath the radical sign, we can combine these. This would be a 1, so 1 plus 2 is 3 cube roots of 5. Alright, last example. We're going to do this one. We're going to do some subtraction. Same thing. We have to have the same index and the same number underneath our radical sign. So our radicand has to be the same. 2 we can't break down, so we're going to work with the cube root of 54. So perfect cube, we're going to use our cube root chart, our perfect cube chart, and number that goes into 54 is 27. 27 times 2 minus, and if we want we can put a 1 in front of this, the cube root of 2. Simplify this, the cube root of 27 is 3, so I'm going to have 3 times the cube root of 2 minus 1 cube root of 2. Since we have the same index and the same radicand, we can combine these. So 3 minus 1 is 2 cube roots of 2. And that, ladies and gentlemen, is our answer. So that's all I have for examples for you. I need you to get one note in your foldable. This one right here. We already had the multiplying and dividing one. Now we have adding or subtracting. We must have like radicals. So what's underneath the radical symbol? This must happen. We also must have the same index, and then we can combine our like terms. Alright, ladies and gentlemen, that is all I have for you today. I hope you are having a spectacular day, and I will be seeing you soon. Bye!